Hi guys, this is Mrs. Hain. I'm going to be reading your science assessment to you today. It does look like it's scanned in as 18 pages, but don't worry, I think there's only like 1 or 2 questions per page. If I don't hit all of the questions in this one video, there may be a second video if it takes too long for me to record the first video. So a couple of things before we get started. Make sure you put your last name, first name, and mark the hour in which you have Mr. O'Boyle. I am going to be reading fairly quickly, so make sure you're paying attention. You can also hit pause in between each question, which I suggest you do, so that you don't get left behind. Question number 1. 2 pine cones are falling from a pine tree. Both pine cones are falling at the same speed. If pine cone 1 weighs less than pine cone 2, which pine cone has more energy upon impact? Both pine cones have the same amount of kinetic energy. Pine cone 1 has more kinetic energy. Pine cone 2 has more kinetic energy, or neither pine cone has any kinetic energy. So again, I would hit pause right here so that you can think about your answer and then hit play when you're ready to move on. Question number 2. What factors contribute to the pine cone's total energy at impact? Speed, which is velocity of the pine cone at impact. Both speed and velocity contribute to the overall momentum and overall energy at impact, or mass of the individual pine cones. Number 3. A balloon with a static electric charge is placed near a student's hair, causing the hair to stand up. Which of the following would increase the attractive force that the balloon exerts on the student's hair? Changing the side of the balloon facing the hair, increasing the strength of the charge on the balloon, increasing the size of the balloon, or the force remains the same if the balloon is moved or the charge is changed. Number 4. A system you are studying contains 4 parts. 1, the Earth's surface, the ground. 2, a tree. 3, a frisbee stuck in a tree. And 4, a frisbee resting on the Earth's surface. The frisbee in the tree falls to the ground as the frisbee is falling. Kinetic energy of the frisbee is increasing and potential energy is decreasing. Kinetic energy of the frisbee is decreasing and potential energy is increasing. Both kinetic energy and potential energy of the frisbee are increasing, or kinetic energy and potential energy of the frisbee both stay the same. So you can hit pause, or you can go back and listen to the question again if you need to. Number 5. You throw one of the frisbees back up into the tree where it comes to rest on a branch. Potential energy of the system increases. Potential energy of the system decreases. Potential energy of the system does not change, or potential energy of the system increases and then decreases. Number 6. The kinetic energy of object 1 is greater than the kinetic energy of object 2. How does the speed of object 1 compare to the speed of object 2? Object 1 is moving faster than object 2. Object 1 is moving slower than object 2. Object 1 is moving slower than object 2. Object 1 is moving at the same speed as object 2. The only way to know which object is moving faster is also know the mass of each object. Number 7. 2 magnets are at rest on a table as shown in the diagram below. In order to get the 2 ends of the magnets marked N to touch, which of the following is true? A force must be applied since the 2 ends marked N repel each other. A force must be applied since the 2 ends marked N attract each other. The magnets will not touch without any force being added. Number 8. Which of the following statements about electric and magnetic forces is true? Both electric and magnetic forces can be attractive. Magnetic forces can be repulsive, but electric forces cannot. Electric forces are not affected by distance, but magnetic forces are. Or magnetic and electric forces do not interact. So just as a reminder, if I'm going too fast, then you need to hit pause and think about your question. But if you need to re-listen to a question, you can always go back and do that. Number 9, 2 strong magnets are attracted to each other and are touching, as shown in the diagram below. You pull them apart. What will happen to the force the magnets exert on each other as they move apart? As the magnets begin to move apart, they immediately stop exerting a force. As the magnets begin to move apart, the force exerted increases. As the magnets begin to move apart, the force exerted decreases. Or as the magnetic begins to move apart, no change in force occurs. Number 10, examine the system model below, which shows a car moving along a track at 2 different points in time. Assume there is no friction between the car and the track. In the before image, a car is moving along the track at a constant speed towards a motionless wheel. In the after image, the car has contacted the wheel, which begins to spin. The car continues to travel along the track at a slower speed. Finish the sentence for the claim. The wheel begins to spin because potential energy is transferred from the car to the wheel. Elastic energy was transferred from the car to the wheel. Kinetic energy was transferred from the car to the wheel, or no energy was transferred. Number 11, examine the system model below, which shows a car moving along a track at 2 different points in time. Assuming there is no friction between the car and track, in the before image, a car is moving along a track at a constant speed towards a motionless wheel. In the after image, the car has contacted the wheel, which begins to spin. The car continues to travel along the track at a slower speed. Evidence: the motion of the wheel after contact with the car, the slower motion of the car after contact with the wheel. Is the evidence stated true or false? Number 12, examine the system model below, which shows a car moving along a track at 2 different points in time. Assume there is no friction between the car and the track. In the before image, a car is moving along a track at a constant speed towards a motionless wheel. In the after image, the car has contacted the wheel, which begins to spin. The car continues to travel along the track at a slower speed. Reasoning: before the car contacted the wheel, it was not moving. After the car contacted the wheel, it began to spin, which means kinetic energy was added to the wheel. It began to spin, which means kinetic energy was added to the wheel in order for the kinetic energy of the wheel to increase. Energy must have been transferred to it from the car. The slower speed of the car shows that its kinetic energy was reduced. True or false? Number 13, using the graph provided, when a ball with a mass of 10 grams is thrown, what is the kinetic energy of the ball? 75, 25, 82.5, or 100? Number 14, using the graph provided, when a ball with a mass of 20 grams is thrown, what is the kinetic energy of the ball? 100, 150, 200, or 250? Number 15, using the graph provided, when a ball is thrown at 10 meters per second, what is the kinetic energy of the ball? 75, 100, 150, or 200? (16) Using the graph provided, when a ball is thrown at 20 meters per second, what is the kinetic energy of the ball? 100, 200, 300, or 400? Number 17. Using the graphs for kinetic energy, mass, and speed, doubling the mass of a moving object has what effect on its kinetic energy than doubling the speed? A larger effect, a smaller effect, the same effect, or there is not enough information to tell? Number 18. Which electromagnetic lifted the most paper clips? So you're going to look at the paper magnetic A, B, C, and then you're going to look at your graph for paper clips lifted for magnet A, B, and C. Which one lifted the most paper clips? Magnet A, magnet B, or magnet C? That's the end of your test. Make sure you go back and re-listen to any questions that you might need to hear again, and good luck.